We talk about three regimes of lubrication, but for this class, we mainly focus on full film hydrodynamic lubrication. And here I show two cylinders. Actually, the outside one is the inner surface of the bearing, and the inner one is the outside surface of the shaft we call journal. So this is the journal surface and the bearing surface. And we assume these two surfaces are rigid and ideally smooth. We flood this gap, okay, which is the clearance between these two surfaces, okay? And we flood this gap by a fluid. Oh, by the way, this gap, actually, I show here, I exaggerate the gap. Actually, the gap is very thin. It is guaranteed by tolerance. So once I have fluid in between, I let fluid go. And then load is applied, and the journal center is going to sink like this. And then the motion is given, and then the journal center is going to be displaced like this. So finally, the journal surface settled at this location. Okay, and then the film thickness in this circumference or in this, around this journal will be different at different locations. All right, but we can find, what we can do is that we can link the two centers and by a straight line. It has an angle to the vertical location, which we're going to talk next time. But now we need to find out how to express the variation of the film thickness, or here we see the gap. Okay, and we can find out this. We can immediately find out this minimum film thickness location, which is H minimum. We call minimum film thickness. Okay, and that is right along the center line. Okay, you can see that. That is defined by clearance minus the offset here. And because this film thickness, this side, the gap or the wedge between the two surfaces is convergent. And beyond that, going from this to the other direction, the wedge becomes divergent. So on the convergent side, we build the hydrodynamic pressure. So pressure is built in this direction like this, okay, which we will talk next time. All right, so as I mentioned, the distance between the centers, which means the original center and the displaced center, is something called eccentricity, which we can define one here and here too. So basically between along this line and between the two surfaces, the original position and the displaced position. Okay, and then at any location, so I just arbitrarily define these at this angle. So this the angle from the current location I'm talking about to the center line. Okay, I define that as a theta. So here, so between the two surfaces, these two solid lines, between the bearing surface and the displaced journal surface. Okay, basically we define the film thickness. I won't go through a rigorous derivation, but it's just show to illustrate this by such a diagram. So the film thickness, which we define as H at any of these locations, okay, and that is something I'm drawing over here, this red line, okay, that equals the clearance, the original clearance, plus eccentricity multiplied by cosine of this angle over here. I'm going to illustrate that. Okay, so now H, I show that here already. Now C, okay, this is H. All right, C is, okay, basically between the original two surfaces, which is the bearing surface and the journal surface. Okay, show C, which that is very easy. You can see that easily. Now, the next item, which I'm going to I want to point out what C is. Next item is this E cosine theta. I show it over here. So E cosine is because the angle is defined by these two lines. Already you can see that. All right, I project this E into the line that we are talking about, the location of film thickness we are talking about. So I can do the similar thing at here, at this location, okay? If I do the same thing, I project this E to the parallel location, which is parallel to this position, all right? So the relationship here and here are the same, basically just E cosine of this angle, all right? So you can see these three lines add together gives us the film thickness, okay? Now we can define, all right? What is eccentricity? So eccentricity, as I mentioned, but now I'm writing that down. So eccentricity equals the clearance, okay, clearance minus the minimum film thickness. So we define that as E, okay. And then the other things that we want to normalize this eccentricity, okay, how to do that? So eccentricity divided by clearance C, and then we get a non-dimensional eccentricity. We call that eccentricity ratio. Okay, then the film thickness, this equation, okay, this equation over here, we can express that differently. So I copy the equation on top, and then I utilize this eccentricity ratio, which means I bring the C out, all right? Then we get inside 1 plus eccentricity cosine theta. So now we have the expression for film thickness. We also define eccentricity and eccentricity ratio. We also know the concept of concept for the location of the journal once motion and load are applied. All right. We also define this convergent wedge and divergent wedge.